Before we know the formula that is being used in negative binomial distribution, we need to know and understand the independent Bernoulli trials, where we have a series of trials and each one results in a success or a failure. In independent Bernoulli trials, there are three types of distribution, which are binomial distribution, negative binomial distribution, and geometric distribution. But this video is not going to tell you in detail about binomial distribution and geometric distribution. This video is only going to help you to recognize the differences between binomial distribution, negative binomial distribution, and geometric distribution when a certain situation is given. Let's go to binomial distribution. It is a distribution of the number of successes in a fixed number of independent Bernoulli trials, which the number of successes is denoted by x and fixed number is denoted by n. Meanwhile, negative binomial distribution is the distribution of the number of trials needed to get the kth success. Geometric distribution has a slightly similarity with negative binomial distribution, which it is the distribution of the number of trials needed to get the first success in repeated independent Bernoulli trials. We can differentiate the negative binomial distribution and geometric distribution by looking at the number of success. For negative binomial distribution, the situation will tell you about certain amount of success, but in geometric distribution, the situation will tell you about the only first success in repeated independent Bernoulli trials. So, to sum up, the definition of negative binomial distribution is the distribution of the number of trials needed to get the kth success. In other words, it refers to the probability of number of trials needed to get success, which means k will be given. The probability distribution of negative binomial distribution is given by the stated formula, which are x is the number of trials needs, k is the fixed number of successes, and p is the probability of success. How do we recognize and identify the negative binomial experiment? Consider the following statistical experiment. You flip a coin repeatedly and you count the number of times the coin lands on heads. Then you continue flipping the coins until it has landed 5 times on heads. This is a negative binomial experiment because the experiment consists of repeated trials. We flip a coin repeatedly until it has landed 5 times on head. Then, each trials can result in just 2 possible outcomes, which are heads or tails, meaning that we can get 2 possible outcomes, which are success or a failure. Then the probability of success is constant, which is 0.5 on every trial. The trials are independent, that is, getting hits on one trial does not affect whether we get hits on other trials. And last but not least, the The experiment continues until a fixed number of successes have occurred, in this case 5 hits. Let's have a closer look on the questions and examples given. The first situation takes place in a bowling lesson. A player is taking a bowling lesson whereby his coach indicates that the player's chance in hitting a strike is 28%. What is actually the probability that a player hit a fourth strike on the sixth throw? Before we solve the probability, we need to identify the information given from the situation. There are 3 types of information, which are X, K, and P. X is the number of trial success to get the rth success. In this situation, X is the sixth throw. K is the number of success in trials where the player hit the fourth strike, and P is the probability of success where 0.28 is the player's chance in hitting a strike. After we identify the point, we can enter the value into the given formula and we will get the answer by 0.0319. Let's jump into different situation. In a sales company, every salesperson are required to complete 8 sales calls a day. Every day, there are 33% chances that a person with selected phone number will answer their calls. What is the probability on the 14 dialed number that the salesperson would be done for the day? As for these questions, we have extracted X, which is 14, as the success dialed number, K as the 8 completed success sales call a day, and P, which is 0.33, as the probability of dialed success. After we get all the information, we can enter the information in the negative binomial distribution formula and we'll get the answer by 0.0503.